Now, yes, now it is visible, students.
Yes, ma'am.
Yeah. Now, okay. Now here we'll calculate distribution bars. AST minimum is equals to 360 mm square. So here we will provide 8 mm dia bars. So spacing formula is equals to pi by 4 into 8 square by 360 into 1000. Calculation will get 2. So dia at 300 mm center to center at both the sides in vertical directions. In the next step, students, here what we will do, we will calculate the design of counterfort. Here in counterfort, we are going to calculate horizontal ties as well as vertical ties. Now see the student, see here students, width of the counterfort is 300 mm. Spacing of counterfort is 3 meter center to center. Now we have to find the theta, that is inclination of counterfort with horizontal. Theta is equals to tan inverse of 6.5 by 2.9 as we can see in the figure. So after the simplification, you will get theta is equals to 66 degrees. Okay. In the next step, we will calculate depth of counterfort. Okay. Yes. Here, depth of counterfort D for beam. Okay, across the junction. So D is equals to capital D minus effective cover. So here, small d. Okay, we have to calculate. So effective cover D, capital D. Okay. So the D value is 2900 minus sin 66 degree. Okay. Next, effective cover is 50 we will take for assumption. So after the calculation, simplification, you will get 2599.28 which can be converted or approximately taken as 2600 mm. At any depth H1 below the total height, okay, total horizontal earth pressure acting on the counterfort. So here it is given by the formula Ka gamma H cube by 6 into center to center distance between counterfort. So Ka is 1 by 3, gamma is 18, H is equals to 6.5 cube by 6 into 3. After simplification, we get 823.88 kilonewton meter. So for this earth pressure or this moment, we have to calculate ultimate moment. Answer by 1.5. So we'll get 1235.82 kilonewton meter. Okay. In the next step, we have to calculate area of steel required. So it is given by the formula mu is equals to 0.87 Fy AST D minus 1.005 Fy AST by FCK into B. So here mu is 1235.82 into 10 power 6. How we got this 10 power 6, students? Kilonewton is converted to Newton into 10 power 3. Meter is converted into mm, that again 10 power 3, total 10 power 6. So 0.87 into Fy is 415 into AST, D is 2600 as we calculated above, then 1.005 Fy is 415, AST we don't know, FCK is 20, B is 1000. If you do the simplification by using calculator, you will get AST is equals to 1330.7 mm square. Okay students, after this we have to calculate minimum reinforcement. Okay, here. So minimum reinforcement is given by 0.85 BD by Fy is the formula for slab. So 0.85 into B is 300 into 2600 by 415. So width of the counterfort is 300 mm. So you do the simplification, you will get 1597.6 mm square. So here we are going to provide 4 bars or 25 mm dia. 4 number of bars. So AST provided is equals to 4 into pi by 4 into 25 square. You'll get the AST provided value as 1963.5 mm square. Next steps and the stem. Due to the horizontal earth pressure, the vertical stem has a tendency of separating out from the counterfort. Hence, it should be tied by horizontal ties. Okay. Now, here what we will do, consider 1 meter height. One second, I'll just rotate it. Yeah. Here, consider 1 meter height of the stem. So, direct pull on by wall on the counter force for 1 meter height at the base. So here the formula is given by maximum pressure into center to center spacing. So maximum pressure formula is given by, okay, is given by Ka gamma h into 3 minus 0.3. So 1 by 3 into 18 into 6.5 by 2.7. If you calculate and multiply this, you will get 105.3 kilonewton. So for this force, we have to calculate factored force by multiplying 1.5. You will get 157.95. So it can be taken approximately as 158 kilonewton. In the next step, students, you have to calculate area of steel required to resist the pull. AST is equals to VU by 0.87 F5. We have to substitute here, students. VU is 158 kilonewton. Kilo means 10 power 3 into 0.87 into F5. If you simplify this, you will get 437.6. So here we are going to provide 10 mm dia bars at a spacing of 170 mm center to center. How to calculate the spacing now, students? S is equals to pi by 4 into 10 square. This AST 437.6 into 100. So after calculation, okay, you will get the value of S as 179.5 mm. So similarly with respect to this vertical ties, so we will calculate design of vertical ties. It is the counterfort and the slab. Maximum pull will be exerted at the end of the heel slab, where the downward force is 87.39 kilonewton per meter. So this value 87.39 is taken from the design of heel slab. So here, students, total downward force at D 87.393 minus 0.3. If you do the simplification, you will get to 35.95 kilonewton. So factored force. So by multiplying this value by 1.5, we will get factored force, which is 353.93 kilonewton. So similarly, in terms of horizontal ties, we will calculate here AST for vertical ties. AST is equals to VU by 0.87 Fy. So VU is 353.93 kilo is 10 power 3 into 0.87 into 4.5. After simplification, we will get 980.28 mm square. Okay. So here what we will do is provide 10 mm dia bars. Okay, S spacing we have to calculate pi by 4 into 10 square by 980.28 into 1000. After simplification, we will get 80.12 mm. So we are going to provide here 10 mm dia bars at 80 mm center to center. By this we have calculated horizontal ties as well as vertical ties. Okay.